Right, your chapter notes, because you're going to need to be turning those in. This again is step 1 for the money and happiness at the very top of the page, above the problem you did. The psychologist randomly selected 100 people from each group. Here's your step 1. Just take a picture of it because I'm going to move on in about 5 seconds. And then your critical value. Again, finding critical value and then drawing a picture and shading 7.815. So 5, 4, 3, 2, 1. Take that out, move that over, and then this is our expected values that we found, the first and last ones. So take a look at those. I'll give you guys 5 more seconds to take a picture of that or write it down very, very quickly. That's E24, right down here. Okay, it should be enough time to write that down. And then we found our test stat, 14.149. We did it kind of the long way. .149, and then we, oops, and then you put that into the picture. So here's the picture. Doggone it, stop. And then there's your 14.149, and then you're going to reject the null hypothesis, right? You have to say, as long as you have the picture, you don't have to say why. Just have your picture here shaded and everything. And the last step was step 5, which is now, and it's just as straightforward as that. Enough evidence to reject the claim that the proportions are the same, proportions are equal, is fine. Okay, so 5 more seconds to do this. 5, 4, 3, 2, 1. Okay. Now, here's your quiz problem. Again, this is a 2 by 3, right? Because we have 2 rows and 3 columns. So we're going to first figure out what our step 1 is. So step 1 is going to be that H naught is O sub I equals E sub I, and H1 will be O sub I is not equal to E sub I. And then you have step 2, finding critical value. So here, my degrees of freedom, I have 2 rows and 3 columns. So 2 minus 1 is 1, 3 minus 1 is 2, 1 times 2 is 2. So alpha is 0.05. Degrees of freedom 2, I'm going to get, take this one right here, 5.991. So I'm going to draw my nice little picture. Up, out, shade, 5.991, and we're kind of good there. So you guys should have that, hopefully. And then step 3, you're going to find your first and last expected values. All right, so for this guy, his row total, his column total divided by his grand total, and you'll end up with 30.04. For the other one, you've got, you've got his row total, column total divided by his grand total, and so you'll end up with 570.1. And then you're going to put everything into chi-squared, and put this into matrix A, do a chi-squared test on that one, and you'll get 112.4 way out here, right? My critical value is only 5.991. It's way back over here. So we're totally going to reject H naught, and there's completely enough evidence to reject the claim that the proportions are the same. That's all you have to do, reject the claim that proportions are the same. That's absolutely an acceptable way of doing that. All right, so any questions on that one before we move on? We got the chat open. Close the bracket. Okay. I had to do problem. I had to do problem 3. That was, why did I go over the other problem? That's confusing. Okay. Wait, what was the last problem I just went over? That wasn't birds and reptiles? That was robbery and homicide. The heck? Okay. So problem 3 on your worksheet was this one here. I don't know where the robbery and homicide came in. That was from a long time ago. Oh, that was the quiz, I guess. All right, so problem 3 on your worksheet. The first one is O sub I is equal to E sub I, and H1 would be O sub I is not equal to E sub I. And then step 2, finding your critical value. So my degrees of freedom is 2 minus 1 times 5 minus 1, so that's 4. So alpha is 0.05. That's not here, not that one. Don't grab that one. It's this one right here. And then 4, so it's 9.488. That's your critical value. And then you're going to draw your little picture here, right? And this is going to be 9.488. You should shade a little bit off to the side. And then the next step, finding your first and last expected values. So for the first one, for him, I'm going to grab his row total and his column total and divide by his grand total. I'll get 54.2. For the second one, which is the second row, there should be a 5 there, 5th column, so that's a mistake. This should be a 5. Second row, 5th column. I'm going to grab the row total times the column total divided by the grand total, and I'll get 45.3. Then put this whole matrix, right? All the stuff in black. Put all that into your matrix A, and then do stat test, chi-square test on matrix A, and you guys ended up getting what? Chi-squared equals what? Anybody?
45.314.
Perfect. So that's totally in the rejection region, way in the rejection region, completely. So we're going to reject H naught, which means we have enough evidence to reject the claim that the proportions are the same. Okay. I'll erase that for the next class. So you guys should be all good.
Young?
Yes. Yep.
I think I'm having a bit of a challenge recognizing what the claim is and what's not.
So
in this particular case, go ahead.
So here it would say, is there a relationship? So in this case, they would have said, you could have said, H naught is no relationship, and H1 is a relationship between vertebrate and engendered and threatened. You could have done that, absolutely. And then your claim in that case, if you did it this way, your claim would have been H1, right? Because H naught is always no relationship. So then your claim would be H1, in which case in step 5 you would have said there is enough evidence to support the claim that there's a relationship between vertebrae and whether it's endangered or threatened. So that would have been totally fine as well.
Okay, because that's what I did. Okay.
Totally fine. Absolutely 100% fine.
Young?
Yes.
Professor Young,
Yes.
for this problem we have 2 alphas. There's 0.05.
I know, relax, we're getting to it, relax. It's okay. It's all good. It's coming up.
Oh, okay.
Yeah. Hold on.
Okay.
So then, the question comes of this one. Is the result different for the alpha's 0.01 level of significance? So yeah, thanks for keeping me on my toes, just in case. So the only thing that changes when you change this, only it changes is your critical value. That's the only thing that changes. So now my critical value is going to be 0.01. I'm going to use this one here and roll down and degrees of freedom 4, and it's going to be this guy right down here. So 13.227, and that's not going to change anything at all, because even if it's 13.277, my test stat is still way out here at 45, so I'm still going to reject, and there'd be no difference. So the result would not be different at all. It just, you know, I would still be rejecting H naught, because 45 is still way out in the guilty region, even if it was alpha 0.01. Good. Makes sense. Does that make sense for everybody? The only thing that changes with this is my alpha, my critical value. Right? My alpha affects my critical value. So then my critical value becomes 13.277 instead, and I'm still going to, it's still in the rejection region. Okay.
So on the test, we'll have to find the two CVs then? Possibly. Okay.
Yeah. There will be a problem. We'll have to do that. Honestly, it'll be this one, or if it'll be a different one. There'll be one problem along this chapter. I may do that. Yeah. All right. So let's get into ANOVA. So ANOVA is when you're testing means. So my H naught is always going to be that the means are equal. Mu1 equals mu2 equals mu3 as many means as I have. H1 would be at least one differs. You don't know which one differs. You can't say that mu1 is not equal to mu2 because you don't know which one is different. So at least one differs. So again, this is really complicated. We're only going to use the TI 8384 to give us results, and we're going to just use those results to proceed from there. So we're going to use the TI 84 to get a p-value, and again, p-value is the probability of getting a sample like yours. So if your probability is really small, if it's really unlikely, then you're going to reject H naught. Right? So in other words, if your p-value is less than or equal to alpha, typically our alpha is 5% or less. Right? So our guideline for unusual is 5% or less, because our alpha is usually 5% or less. So if your p-value is less than or equal to alpha, then it's unusual. Typically 5%, sometimes other things. But you know, if it's less than alpha or equal to alpha, we're going to reject the null hypothesis. If it's greater than alpha, then we're all good. Everything's fine. No big deal. And then let's talk a little bit about this difference in variance in the means. Okay, so so we're looking at variances. And we're looking at the variance between groups, and we're comparing that to variance within groups. When the variance between the different groups is really big compared to the variance within the groups, then we're going to reject the null hypothesis. And I want to kind of show you what I'm talking about here. Let me go ahead and show you what I mean. Close. Make this a little bigger, I think. Okay, good. So imagine I have a bunch of first graders, and their heights are all like right around here, right? They're going to vary. They're going to vary in this range, so they're going to vary about that much. And then we have a bunch of fourth graders, right? And the fourth graders, maybe they're a little bit taller. They're going to vary about this much, but that's their variance. And then we have these 12th graders, and they're up here. They're taller than me. Their variance is up here. So they're within variance. It's all about this much, right? This much, that much. So not that much, right? Not a whole lot. But if I look at the variance between the groups, between my kindergartners and and the fourth graders, it's like a really big variance, right? The variance is from up and down to here, right? It varies that much. So my between group variance from the seniors to the kindergartners to the fourth graders and back is really big. If I compare that to the little variance within the group, those are really small, so it's going to be a lot bigger, right? That proportion of taking those two, I'm going to get a number much larger than 1 when I compare them, because the between group variances are much larger than the within group variance. Right? My first graders, they have an average of around 42, with a small variance of maybe 5 inches. And the fourth graders, they have a variance of around 5.5, and the 12th graders may have a little more. But if I look at the variance between these two, between 42 and 66 and 59, those are much bigger, variances. Those distances are like 24 inches. That's much larger than from 39 inches to 46 inches. There's a lot less difference, right? I'm looking from if I'm comparing 39 to 46 versus comparing 39 to 69, that's a much bigger difference. So looking at these variances is what we're doing. So that's where this comes from, the F-stat. It comes from comparing your variance between the samples, right, from the first graders to the fourth graders to the seniors in high school. That big variance compared to the variance within the sample, right? So within just amongst the first graders, or just among the fourth graders, or just among the seniors. And when the variance between the samples is a lot larger, then we say that the means are not the same, which makes sense, right? Because you're going between a bunch of different groups. If they're all about the same, then they'd be roughly the same. So on the final, I'm going to give you a question. I'm going to give you the between group variance or the between sample variance, and I'm going to give you the within group variance or the within sample variance, and some other stuff just to confuse you. I'm going to ask you to compute the F statistic. All you got to do is grab the between group variance or the between sample variance and divide by the within group variance or the within sample variance, and that's it. It'll be, so some of you guys will be like, oh wow, that was the easiest 2 points on the whole exam. And others of you will be scratching your heads because will have not written down this formula here and you'll have forgotten what to do with it. So you make sure that you have that. All right, so again, these are the steps for ANOVA. State the hypothesis. H naught is always going to be mu1 equals mu2 equals mu3 equals mu4 as many mu's as you have. H1 is at least one differs. Not which one. You can't say which one because you don't know which one, but at least one of them differs. Next, you're going to find alpha. Alpha equals whatever, 0.05 or 0.1 or 0.01, and then compute the p-value. So you're going to put the first group into list 1, next group into list 2, and so on. Put all the groups into a list, and you're going to do stat test ANOVA, parentheses, and then list all of your lists, L1, L2, L3, L4, L5, how many lists you have. The commas above these 7, again, just in case you can't find it. And then you're going to make your decision to reject H naught or not. Remember, if the p-value is, if it's unusual, the p-value is less than alpha, less than or equal to alpha, you're going to reject the null hypothesis. And in summary, either you will or will not have enough evidence to reject the claim that the means are the same. And that's basically it. All right, so we're going to go ahead and go through quiz number 2, assuming you guys are ready for that. So you should have been working on that a little bit. Here's quiz problem 2. So here is our hypotheses. Again, same thing. And again, it's not mu1 is not equal to mu2, none of that stuff. It's just at least one differs. You don't know which one differs, but at least one of them differs. Alpha is 0.05. Done. That's it. Compute the p-value. So stat test ANOVA of L1, L2, L3. I get a p-value of 0.0545. Do not round the p-value. And give me the p-value to 3 sig figs. What's a sig fig? That means you go along the decimals until you get to your first non-zero, and then you count. 1, 2, 3. Done. 0.0545. That's it. 3 sig figs. And then make the decision. And here I'm not going to reject the null hypothesis because my p-value is greater than alpha. Here's a hint. Make alpha, add zeros to alpha at the end to give it the same number of decimal places. And then they both have 4 decimals. 4 decimals, it's easy to compare 545 to 500. That'll just make it easy for you to wrap your heads around if you are confused about decimals. That would be my suggestion. So since we rejected the null hypothesis, since we did not reject the null hypothesis, we do not have enough evidence. Oops, that's wrong. Why is it not giving me an option to do this? This is strange. No worries. I'll just add a not to the end. Not enough evidence. There. So there's not enough evidence to reject the claim that the means are the same. Okay, good. Everybody on board? Questions?
Yeah.
Go ahead. Yes, you're ready to move on, or yes, you had a question? Okay, I'm going to take that as yes, you're ready to move on, because I didn't hear a question.
We can move on.
Okay. Great. So lab problem 1, go ahead and do it. I'll give you guys just not a lot of time, 5 minutes. Breakout rooms. Hop in. Here it is. So this is on the next page of your chapter 11.3 notes. It is the bottom of your second page. This is the page you're turning in today. We did the first one last time. The fuel economy we did last time, and then you're doing the bottom one today. And we're doing the rest of this whole thing today, actually. So 5 minutes. All right, so second page of your 11.3 notes. Here's your 11.3 notes right here.
And how many pages are 11.3 perfectly on?
There's only 3 pages to it. Doesn't have very many
3
pages.
pages.
Yeah.
Oh, okay.
Yeah. So it's only got 2 sheets of paper. We did this one last time, and now we're doing lab problem number 1 below.
Yeah, I don't.
All right, so if you got the packet from me, it's all one big packet all together, chapter 10, 11, and 11.3 all together. And it's the second to last page. You go to the back, which is blank, you flip it over, and then it's the next to last written page. Okay, so we are back now, I believe, and this is our lab problem 1. So our null hypothesis is, again, mu1 equals mu2 equals mu3. H1 is at least one mean differs. And remember, for the exam, I'm always going to make H0 the claim for chapter 11. So for the exam, H0 will be your claim for chapter 11, and for chapter 10, H1 will be your claim. However, for the book, it's going to vary. So for your homework, it's going to vary. So for the homework, it's going to say, conclude there is a significant difference. So the difference means that at least one differs. So that means for the book, for your homework, H1 will be your claim. But again, on the exam, I'm always going to make H0 the claim for chapter 11. All right, so then the second step, find alpha. Alpha is 0.05. Compute the p-value, so I'm going to put this into list 1, this into list 2, that into list 3. Stat test ANOVA of L1, L2, L3. I'm going to get a p-value of 0.0212. 3 sig figs. Just give me 3 sig figs. Get to your first non-zero. And so here's my 2 is the first non-zero, and then second, and then my third. 3 sig figs right there. All right, so then we're going to reject the null hypothesis since my p-value is less than alpha. Maybe, add a couple of zeros to alpha if you need to, if you get a little lost with the decimals, so they have the same number, they both have 4 decimals then, and you can see at 500 is definitely bigger than 212. So p-value is small. Remember something like, what was that phrase my student said? It was p-value low, H0 must go, p-value high, H0 will fly. In other words, it's a go. It's that flies. It's fine. that was kind of a nifty thing that I don't know where she got it from, but it's cool. All right, and then summarize your results. So I should probably retype that so that they're in different sections. Hold on. So that it not, you can tell them apart a little bit better. Okay. And maybe I'll move it over. There. Okay, great. Step 5, summarize the results. So you could say, if you're going the way the textbook would give it to you, is there is enough evidence to support the claim that there's a difference among the means. That would totally work. On the exam, you could also, if you wanted to, just say there's enough evidence to reject the claim that the means are the same. Because I'm always gonna just, for the exam, it's always going to be rejecting claim for chapter 11, which is 11.1, 11.2, 11.3. That won't be true for chapters 8, 9, and 10, though. Don't go pulling that for those. It's only for the chapter, the chi-squareds and the ANOVA. The line stuff, like the stuff you're doing in your lab, that stuff is going to be, H1 is going to be my claim. Because typically you're saying there is a relationship, or there is a correlation. That's usually your claim. Okay, so here is the summary of that, in case you were unsure. And I want you guys to go ahead and do lab problem number 2, which is on the next page. It's the study done about the recent surge in gasoline prices with the hybrid cars, the hybrid SUVs, and the hybrid trucks. So next page, on the next page, go ahead and fill out quiz problem 2, which is, or lab problem 2, which looks like this. All right, I'm going to open up the rooms and give you guys just 5 minutes again. I think it was 5 minutes enough? You guys had enough time to do that, yeah? Yes, no? All right, I'm going to assume that's a yes, because I didn't hear from anybody.